Hello everyone. We are given a seventh degree polynomial in the S domain and we are asked to find the number of roots of the polynomial in the open left half of the complex plane. To know more about the concepts used to solve this problem, kindly refer the NPTEL Control Engineering course Week 4 Lecture 2 by Professor Ramkrishna Pasumarthy of IIT Madras. The number of roots of the characteristic polynomial on the right half of S-plane can be found by computing the number of sign changes in the first column of the Routh-Hurwitz table. A row of zeros in the Routh-Hurwitz table can be replaced by the coefficients of the derivative of the auxiliary equation. So in this question, we are given a characteristic polynomial, that is s raised to 7 plus s raised to 6 plus 7s raised to 5 plus 14s raised to 4 plus 31 s cube plus 73 s square plus 25s plus 200. So we are asked to find the number of roots of this polynomial on the left half plane. For that, we'll first construct the Routh-Hurwitz table. So now let us fill in the Routh table. So we will first fill in the coefficients of the polynomial. So we will have 1, 1, then 7, 14, 31, 73, 25 and 200. So now let us find this term. For that we have to do 1 times 7 minus 1 times 14 divided by 1, that is 1 times 7 minus 1 times 14 divided by 1, which is equal to minus 7. So I'll write down minus 7 here. Now this term can be found by 1 times 31 minus 1 times 73 divided by 1. So you have 31 minus 73 divided by 1, which is equal to minus 42. So that is minus 42. For the third term, you have 1 times 25 minus 1 times 200 divided by 1. That is 1 times 25 minus 200 divided by 1, which is minus 175. Is minus 175. So there is no term here. So now you can use the same way to get the next row. That is minus 7 times 14 minus 1 times minus 42 divided by minus 7. So you will get 8 here. So the next term, similarly you will get 48 and then the 200 here. Now when you compute the next row, that is 8 times minus 42 minus minus 7 times 48, you will get 0. And for the next term, 8 times minus 175 minus minus 7 times 200, you'll again get a 0. So now we have a row of zeros. So now to proceed, we need to find the auxiliary polynomial. So we can find the auxiliary polynomial using the row above the row of zeros. So that is this row. So the auxiliary polynomial is a of s 8s raised to 4 plus 48 s square plus 200 equals 0. Now let us differentiate this. So dA by ds equals 8s raised to 4, you will get 32s cube plus 48s square. So you'll have 96s plus 200, which is 0. So now this is the coefficient which you can replace here. So that is 32 and then 96. So now you can proceed with the same method to get the next rows. So you will have 32 times 48 minus 8 times 96 divided by 32. That is 32 times 48 minus 8 times 96 divided by 32. So which is equal to 24. So this term here is 24. And similarly for the next term, you have 32 times 200 minus 8 times 0 divided by 32, which is 200. Now you can find this row. So you have 24 times 96 minus 32 times 200, that is 24, times 96 minus 32 times 200, divided by 24, which is equal to minus 512 divided by 3. So that is minus 512 divided by 3, and there is no term here, so that is 0. And for the final term, you have this term times 200 minus 24 times 0 divided by this term, so you'll have 200 itself. So now let us count the number of sign changes in the first column. So you have a sign change here, and then another sign change here, one sign change here, and another sign change here. So we have in total 4 sign changes, so which means the number of roots on the right half plane is equal to 4. So, but we are asked to find the number of roots on the left half plane. So which means the maximum number of roots this polynomial has is 7, since it's a 7th degree polynomial. So the number of roots on the left half plane will be equal to 7 minus 4, which is equal to 3. So there are 3 roots in the left half plane. So the correct option to this question is option A, that is the number of roots of the polynomial in the open left half of the complex plane is 3. Thank you.